Welcome to day 46 of our machine learning course. Today we will be diving into the world of unsupervised learning, focusing on clustering techniques and decision trees. By the end of this session, you will have a good understanding of how unsupervised learning can uncover hidden patterns in data. Here's an overview of today's topics. We will begin with an introduction to unsupervised learning and then explore some powerful clustering techniques like k-means, hierarchical, and dbScan. After that, we will take a look at decision trees and their applications in data classification. Finally, we will wrap up with some hands-on practice to solidify your understanding. Unsupervised learning is a type of machine learning where we work with data that does not have labels or predefined outcomes. Unlike supervised learning, where we train the model with labeled data, unsupervised learning allows us to find hidden patterns or groupings in the data. It's ideal for tasks like clustering, dimensionality reduction, and finding with associations between data points. There are three main types of unsupervised learning. First, we have clustering, which involves grouping similar data points together. Second, association helps us discover relationships between variables. Finally, dimensionality reduction simplifies data by reducing the number of features, making it easier to analyze while retaining essential information. Let's start with clustering. Clustering groups data points into clusters based on their similarities. It's widely used in customer segmentation, anomaly detection, and even image segmentation. The goal is to identify natural groupings within the data without needing any predefined labels. One of the most popular clustering algorithms is k-means. The idea behind k-means is simple. We choose a number k for the clusters, randomly assign centroids, and then assign data points to the nearest centroid. We repeat this process, recalculating the centroids until they stabilize. It's a straightforward yet powerful technique for many real-world clustering tasks. Here's an example of how k-means work. We start by selecting k initial centroids, then each data point is assigned to the nearest centroid. Over time, the centroids are updated and the data points are reassigned based on the new centroids. We can determine the optimal k by using the elbow method, which helps identify the best number of clusters for your data. Next, let's talk about hierarchical clustering. Unlike k-means, which divides data into a fixed number of clusters, hierarchical clustering builds a tree-like structure called a dendrogram. This tree shows how clusters are nested within each other, which can be useful for understanding relationships between data points at multiple levels of granularity. Another important clustering method is dbScan, density-based spatial clustering of applications with noise. dbScan is great for handling datasets with noise and irregular shapes. Instead of specifying the number of clusters, dbScan groups points based on density, making it ideal for complex, non-linearly separable data. Now let's shift gears and look at decision trees. Decision trees are a supervised learning technique, but they are incredibly useful in understanding how data can be split and classified. They work by recursively splitting the data based on feature values, with each split maximizing the separation of the classes. This process creates a tree structure with decisions at each node, which makes it easy to visualize and interpret. A decision tree works by splitting the data into subsets based on feature values that best separate the classes. To decide how to split the data, we use metrics like Gini index or entropy, which help determine the quality of the splits. The tree grows until all the data points are classified and we can prune it to avoid overfitting. Let's now put this into practice. We will use a dataset such as the Titanic survival dataset to build a decision tree. Using a tool like scikit-learn, we will create a tree that classifies whether a passenger survived or not based on features like age, sex, and class. We can visualize the tree to see how the decisions are made at each step. To reinforce what we have learned, here's, a, here's your practice assignment. Use a movie ratings dataset to perform clustering and group similar users based on their performances. Once you have created the clusters, analyze the results and try to interpret the patterns in the data. This hands-on experience will help solidify your understanding of supervised learning. To summarize today's lesson, we learned that unsupervised learning helps us discover hidden patterns in data. We explored several clustering techniques like k-means, DB-scan, and hierarchical clustering. We also introduced decision trees and their application in classification tasks. Remember, practice is key, so continue experimenting with these techniques to master them. That wraps up today's lesson. If you have any questions, feel free to ask now. I hope you found this session informative and helpful in your journey to understanding unsupervised learning. Thank you for joining, and I will look forward to seeing you in the next session.